First thing we have to do our polar form. What's the modulus of this? Root 30. Let's just keep it at root 32. 16 square rooted. Cosine. What's the angle here? Are we starting to recognize when it's an isosceles triangle?
The angle should be pi over 4, yeah.
Okay. What quadrant is that in?
The quadrant that is on the bottom left, so it should be negative 3 pi over 4.
Okay. Yeah, so we're here, aren't we? So we're looking at this angle. So that'd be negative 3 pi over 4.
Because we know the quadrant and it's an isosceles, so we know it's a pi over 4 angle, and so we just find it.
It's an isosceles, 2 lengths of 4.
Oh, yes.
Has to be isosceles, yeah. And the
Symmetrical. Yes.
Yeah.
Yes, it is.
and it's in this quadrant from its position, so I know that both angles need to be the angle, the argument needs to be negative.
An equilateral is also a form of isosceles, right, sir? Which means it would also be
Oh,
pi over
yeah.
4?
No,
No?
it's an isosceles triangle, but it's not a right angled triangle.
Oh, right. Yeah, that's how that works.
Okay, so this is a right angled isosceles. All right. All right, at this stage, the other side, we're going to do this or5 thing, cosine, that's not how you write a 5 theta plus I sine 5 theta. You can skip that step if you want. Too hot? Too hot. Too hot. Okay. Okay. All right. What's our modulus going to be? Almost a tricky question in itself. The mod is going to be, well, root 5 is equal to root 32. So what's or is equal to?
That's not.
Which?
Could you like convert that into whatever it is?
You could probably logic it out if you want. It's not 2. If it was this, it would be 2.
Oh, 1 over 2?
It's-
Is it 1 over 2?
It's root 2. Anyone figure out how that would be? Gone too. Yeah, so it's 5 is, that's 2 to the power of 5 to the power of a half. Isn't it?
Yes.
Which is 5, or 5 is 2 to the power of 5 over 2.
Which is root 2 to the 5. Yeah.
Which is, yeah, that's, you could do root 2 to the power of 5. And now, or must be root 2. No, it takes a second. That's not the easiest way to do it. You could logic it out a little bit easier than that. You'd never do that? There's definitely other ways. You could square both sides, and that'd be or to the power 10 is 32, and then, I don't know if that's easier, 10 root. Anyway, so it's or is root 2, I don't need to rub that out. So you get cos 5 theta is equal to cos minus 3 pi over 4. So 5 theta is minus 3 pi over 4.
And then plus k, 2k pi.
Plus the 2k pi. Then divided by 5. So this is a bit messy. Let's write this as 8 over 4. Because I'm going to divide it by both by 5 and then have a common denominator ready to go. They're both over 20. That makes sense? That's okay with everybody? So that's minus 3 pi plus 8. I divided them both by 5.
I don't see where that 8 came from. If you just divide by 5, would it just be over 20? It's just like minus 3 pi plus 2k pi over 20. Oh, wait. Yeah, is that okay?
No, it'd be 2k pi over 5. And then I'd have to do a common denominator afterwards.
Right.
Was that might have been too... I'll do that slower.
I forgot that the 2k pi
Slow.
is just tacked on.
Negative 3 pi plus 8k pi. I'll just do that again. I went too fast. Plus 2k pi, yeah? Divide by 5. I have theta is equal to minus 3 pi over 20 plus 2k pi over 5. Need a common denominator to put these two together. Yeah, times this by 4, 8k pi. Okay.
Makes sense. Very good.
And our modulus is this, our argument is this, and we need to sub in a bunch of times. 5 times. What numbers we sub in? We'll find out.
He decided.
Whew. Yeah, horrible.
Well, we aren't, because it's not the question, so let's
So
not worry about that.
the general one is root 2 cos minus 3 pi plus 8k pi over 20. I'm just going to write cis just because it's quicker. Okay? That's the general.
That's a K, right? Under the Z.
That's the k.
That's
Here? No, that's an n.
And why is
A general term. Oh, yeah, k, yeah. We're dealing with k. All right, so when k is 0, we start with. Always start with k is 0. We get root 2 cos minus 3 pi over 20 plus I sine minus 3 pi over 20. This is not a known angle. It wouldn't usually be expected to switch this to Cartesian form. Because 0, k is 0. First case, k is 0. Yeah. So that's the solution. That's our first solution. Don't need to convert it to Cartesian because it'll just be a bunch of decimals. A bit of a mess.
irrational decimal?
An irrational number in front of the decimals, which is even better. Yeah.
Oh, wow, that's a lot of irrational.
K is equal to 1. This is a far tidier solution. In the book, or in the book, you'll almost certainly see solutions written like this, which is even tidier still. They shorten it down. What's the next solution to this?
5 minus pi over 20. 5
Uh,
Is it not 5 pi over 20? Yes.
it'd be 5 pi over 20, so root 2.
Minus 3 pi plus 2k. No, it's plus 8k. Because we're doing it over 20 instead of, my bad, I forgot 2.
Okay, so we picked 1, and it's now you could obviously write this as pi over 4. If you want to simplify that. Root 2 cis pi over 4.
We do know that.
Do you know that? 5 pi over 20, isn't that the same as pi over 4?
Yes, we do know that.
We do know that. Because you've left the other one like this, there's no point in
Oh, okay.
continuing. Put one in Cartesian, the other in polar, and some in.
Just saying it would be 1.
It would be 1.
Plus
Pi over 4. Yes, it would. Okay, what do we go next? We go k is equal to, I'm going to keep going, I like to go the positive direction until we exhaust them and then go the negative direction. K is equal to 2. When k is equal to 2, 16 minus the 3, and we get 13. 13. So root 2 cis 13 pi over 20. If I put k is equal to 3, am I too far?
Yeah, you are, because it's 21.
You can't see?
Yeah, your context?
So I'm putting in numbers here for this k. So I'm putting in 0 the first time, so that was just nothing. 1 the second time, so that was 8 pi, take away the 3 pi. The third time, I put in 2. So that's 16 take away 3, which is 13. So this time, I'll test in my head. If I put in 3, what do I get?
21.
I get 24 pi take away 3, which is 21 pi over 20. That's too far. 20 over 20 would be pi. So 21 pi is too far. So we go back. We go minus 1 now. Minus 1 in here. Minus 11. Minus 11 pi over 20. This should be our last one. How do I know it should be my last one?
Another one would be
5. 5, yeah. 5 roots, 5 of them. Awesome. And minus 2 in here, minus 16, minus another 3, minus 19. And that's pretty much at the limit. Okay, there's our solutions. Complicated.
Especially if you don't like the system.
Yeah. Yeah. So hopefully we're finding a kind of pattern that we can do each time. Start nice and slow and then maybe pick up the pace when you're subbing these in towards the end.
Just take the argument and then play around with it using that.
Yeah, the argument plus 2k pi and then divide it by whatever is over here.
It helps that when it's even, you just have to do half of them.
Yes, it does, yeah. There's some properties which we'll just look at before I'll give you some to-dos. There's definitely plenty of symmetry to check your answers. Okay, so some of the properties that you noticed, they read a bit weird. Maybe here. One head in the way. There are exactly n roots of c. So it's the power of n. So if it's the power of 3, there are 3 roots. We gathered that, the power of 5, there are 5 roots. If c is a real number, they will most occur in conjugate pairs.
Which is like the negative positive.
So it'll form this shape.
Yeah.
Yeah? If it's not a real number,
It's a complex number.
a complex number, it mightn't, they mightn't occur in conjugate pairs. They probably won't. They'd be more, I don't think so. It'd have to be on one of the axes. The complex, it won't be in conjugate pairs, but there will be some conjugate. Is it, if it's right on the, if it's like 2i, it'll have some, won't it? Didn't we do the one that had 2i?
No, we had one that was
No, we didn't.
on the 0.
No.
Oh, the one on 0 had like the conjugate
Yeah.
on the other side, yeah, because there was 3 of them. And then the
Yeah,
other
but that,
Okay, that makes sense.
okay. So this is the one you look out for. This one, you'll just have to do them all. This one, they can happen in conjugate pairs if it's a real number, like the 64 we did at the start, or the 1. The roots of z will have the same, all of the same modulus, so we just did that. They all have the same modulus. You can see here they're all root 2. It won't change because they all have to be multiplied by the same power, or put to the same power. They all lie within a circle that has that as a radius. So this forms a circle, and that's the radius is constant throughout. And they'll all be equally spaced out. So the angle between all of them will be the same. All these angles are the same, equal slices of pi. Yes, yes. The angle between them, yes, but not the argument won't be that. Yeah. Okay. Some questions for you. So I took one of these questions and did it. I did question 6 here. This one. That's the one I did. The easier ones are obviously at the start, maybe easier, and these are the more complex ones. Give them a go. Whatever you like the look of. Maybe try one of the ones in question 6. Because it's the one that's on the board is probably the freshest in your mind.
Music permitted?
You don't need music.